Good afternoon, folks. How are you today? We are in lab number 1. Today, we have two objectives. One, we want to graph this function fx is equal to 2x squared plus 1 minus e to the power x to locate its non-zero root. And then we want to find this non-zero root of the same function by bisection method to 4 correct decimal digits. You are going to create templates for this lab number 1. The name of the workbook is going to be lab1.xlsm. M stands for that it is macro enabled workbook. You are going to, in this book, create two worksheets, one named plotting, one named bisection. See template for each on the following slides. So here is our first template. I'm very picky. I would like you to enter exactly in the cells that I am providing because all our formulas would be coded that way. So all your labs should have a lab title. It should have a name. Every worksheet should have your name. It should have the date that you're submitting or preparing the worksheets. And again, I would like you to very much, if I am superscripting something, I would like you to superscript. I usually use Calibri 11 size font. So prepare this simple worksheet. And then the second worksheet, I want again your table headings to be exactly in row 7. I want them exactly like this, X left, X right, with the subscript and so on and so forth. Okay, so let us begin. I am going to fire up my template. So since I saved it as macro enabled file, it is giving me the security warning. So yes, I want to enable the content even though I don't have a macro as yet. So let us begin by naming cells and looking at how we can look up the names that we have created. So remember, we don't want to name labels, we want to name values. So this is our value of xmin. So we want to name it xmin. So we will go to the name box, type xmin, enter. Next one is xmax, enter. Next is our number of points, enter. And next is our delta x, we'll call dx, enter. So we named 4 cells. It's always a good idea, get in the habit of doing this, to look at the name manager to make sure that you have named properly and what those exact names were. So go to the formulas tab, click on name manager, and you will see the 4 names that we have given. You can see their value. You can even make sure that you have even named your worksheet and so on and so forth. Next, we are going to create a macro. To create a macro, you want to make sure that you have a developer tab. So if you already have a developer tab, skip this slide. If not, let's see what you're going to do. So you're going to go to File, Options. In Options, you're going to go to Customize Ribbon. In Customize Ribbon, you are going to look at tabs. So in my case, notice my developer tab is already clicked. If on the other hand you have on the right hand side developer tab and it is not turned on, you can turn it on. Otherwise, if it is not at all there, you can look at tabs. These are your main tabs. You can select developer tab and you can add it. So in my case, I already have it, so I don't need to do it. I have it here. So that's how you get your developer tab. So here is my developer tab. So on developer tab, we want to select Visual Basic and it open up a new window. And in this new window, we want to insert a module. So we want to insert a module. So in my case, I already had a module 1. In your case, you should get a module 1. For some reason, I already had a module 1. So in module 1, you are going to start typing your function. So my function f of x, and notice as soon as I hit enter, it has made this color blue, added another line end function as the end of our this particular function macro, or it's just called Visual Basic function. So I'm going to type f is equal to 2 times x square plus 1 minus exp of x. Notice I did not put any spaces. I typed everything lowercase and I'm going to hit down arrow key. As soon as I hit down arrow key, first of all, it spaces everything apart so that it is easy to read. And notice it capitalized exp, that it recognized this exponential function. So get in the habit of typing everything lowercase, even though you might see in my printout something capitalized, but that is capitalized by the system itself. I did not type it that way. Okay, we have created a macro. So we'll minimize that VBA window. And now we start typing in our formulas. So for delta x, we are going to type equal to x max minus x min divide by n. And our delta x comes out to be 0.02. Cell A8 equals to x min. A8, A9 is cell A8. So we click on A8 plus dx. B8, we are going to type f function of cell A8. And we get this value 0.281718, so on and so forth. So now in this cell, I have a value, I have formula, I have formats and all that. So there is something called a copy fill tool. If you point your mouse to the right bottom corner, you will see this mouse takes this dark plus shape. So if you left click and drag down what is called this copy fill tool, it'll copy all the formulas, formats, etc. Except notice it has updated the cell. So it has updated the cell from A8 to A9. So it'll always be taking function of the corresponding value of the left cell. So now we have these two formulas and we can copy them down as well. So I select both the formulas. I point my mouse at the right bottom corner. It changes to this dark plus shape. And I'm going to drag it all the way to row 59. Okay. So I want to format all the X values to 2 decimal digits. I'm going to say format number and 2 digits. Now let us try to understand why am I picking 2 digits. Let's make it 4 digits. If I make it 4 digits, notice all values have these trailing 2 zeros that are common. So they are extraneous. They don't add anything to our information. So we don't need them. Let's say, suppose I really wanted 2 digits. Suppose I may, no, 1 digit is enough. What will happen? Now, when I choose 1 digit, it is too few because these first 3 values look identical. I have not kept enough digits. So I need at least 2 digits. Same idea is here. I want to make sure that all my values have sufficient digits displayed so that we don't have a lot of leading common digits. So for this, 4 digits is enough. Later on, we'll develop a much more rigorous system of how many digits we should display, at least in our inputs and outputs. And intermediate values, we will just see what we want to see. Okay. So we have our function value table. Now we want to do is we want to change the inputs from 0.1 to 1.1, x min to x max. Because notice when we went from 1 to 2, our function value did not change any sign. We want to make sure that function goes from one sign to another or our curve crosses the x-axis. So we are going to change this to 0.1 and change this to 1.1. Now notice we have negative values and they become positive starting with 0.76. So now we know our function crosses the x-axis. So now let's create a plot. So we'll select labels as well as all our values. Go to insert and we want to select this XY scatter chart and we want smooth curve. That's all we want. Okay. Now it is always a good idea to temporarily move this chart to a new sheet because then we get a lot of real estate and we can format the chart to our needs. So we are going to right click, say move chart as a new sheet. So now we have got this lot of real estate and we want to format it. So let's look at our axes and again do the same thing in terms of number of digits. So when we look at this x-axis labels, we find out that they have this extra trailing zero, which we don't need. So we click on that x-axis and say format axis, and we come to this number and we say 1 digit is enough. Then we select y-axis, and notice here every value has 3 trailing zeros which are extra. We don't need them. So again, 1 digit there is enough. What else do we need? Once we have adjusted this, we want to always give labels. Okay, so we want to have a x-axis label and a function axis label. So typically what we are going to do is we are going to add chart elements. You normally want to start with your chart title. So we want chart title, let's say above the chart. So we already had automatically a chart title it picked up. But if you want to be more explicit, you could have said fx is equal to 2 times x square plus 1 minus exp of x. And I've kind of done my spacing myself. Next thing you should do is add axis titles. So start with horizontal. In our case, it is x. And then do axis title vertical. In our case, it is f of x. So we have a reasonably well documented plot. And now that if we are happy with it, we are finished with the plot, we can move it back as an object in our plotting worksheet. And what we can do is we can drag this kind of towards the top. So it's kind of nestled nicely there. And you might want to size it so that it's about column H. Okay. All right. And what we want to do is we want to find out what is our output. So notice our function went from negative to positive from 0.74 to 0.76. So let's bold it and let's box it. So in this case, we would therefore conclude that if we were forced to say, we would say our root is 0.75 plus minus 0.01. So that is what we would observe. So we say method output root is equal to 0.75 plus minus. So let's insert that. Insert symbol. We want plus minus 0.01. So let's bold this And let's box this. Okay, so we have done the first part of the lab. Let's save this file. So I do save as, and I already have lab1. I don't want to overwrite it. So I'm just going to say, this is my lab1 demo. In your case, you will leave it as lab1. All right, let's look at our second part of the lab. We want to find non-zero root of the function, same function, by bisection method to 4 correct decimal digits. So what we are going to do is we are going to create another function that calculates dx or delta x by bisection method, and it will need two inputs, x left and x right. So we go to our developer tab, Visual Basic. So same window, we are going to add another function. So we start typing function dx underscore bisect xl and xr. Normally I keep all my names all lowercase, but sometimes just to accentuate, I am capitalizing it. It turns out programming languages really like to be case sensitive, so be careful with your case. Again, down arrow, it spaces everything apart. So we are done. Very, very simple functions, notice. Okay, so we are set. We'll minimize this. And let's go to our bisection template. So we start naming cells. So we are going to name this cell A5, which contains the value of x left, XL. This is x right. Now in Excel, it does not matter whether what case it is. It treats the case lower or uppercase the same. But I like to use case just to kind of again accentuate. This is EABS. And as I said, always a good idea once you are done naming cells to check them out. So go to Formula tab, Name Manager, and you can see that they are mixed right now. So if you want to sort them out, here is your 3 bisection names that you just added, XL, XR, EABS. Okay, we start programming. This is our first iteration. Our X left is XL. X right. We will compute the function of this value X left. Compute the function X right. And now we are going to invoke our Visual Basic function dx underscore bisect. And notice I typed it all lowercase, but it picked up the correct VBA function. And we need to give it two inputs, x left and x right. Then our middle value is x left plus this delta x. We compute the function there at x mid. And then our convergence criteria is absolute of delta x, which is this cell, less than equal to EAPS. And we get our answer as false. Okay, so notice we have just typed one row of formulas. And you have to type it very carefully. So in all the future Excel spreadsheets, we would be typically, remember, these were our inputs. So these were given. Real formulas are here. And we are going to put another 3 cells worth of formulas. So in effect, we are putting one row full of formulas, and that is what you will be doing in future spreadsheets. And after that, we are just copying the rows down. Okay, our next row of formulas. So we have iteration that we are going to increment by 1. And now comes our key logic. If the function at left times function in the middle is less than 0, that means our root is in left half. So we don't need to move the left marker. We leave it the same. Otherwise, we move it to the middle. Similarly, if function at right times function in the middle less than 0, root is in right half, we don't need to move the right marker. Otherwise, we move the right marker to the middle. And that's all we need to do. We need to carefully type these equations. Once we have done that, okay, notice that our root is not between 1 and 5. Our root was 0.75 approximately. So now let's change our x left to 0.6. Change x right to 0.8. And you can see that our function at x left is negative, function at x right is positive. We do have a root in between the two. So we are going to copy all of these formulas using copy fill tool, one row down. Still did not converge. So now we have got our iterator. We are going to go another iteration, another. So we are going to keep doing it one row at a time till we converge. So we have converged in 12th iteration. Okay, so let's format our values. All x values, we want 5 decimal digits. So this is x values. These are x values. Right click, format cells, number, 5 digits. So remember, we wanted our x answer to 4 digits, correct decimal digits. So we are displaying an extra digit so that we know how to round up or round down. All function values to 1 decimal digit, because these function values are changing their magnitude wildly. So we want to state them in scientific notation. So we want scientific 1 digit. And then we are going to box our final answer. Maybe even bold it. So our method output is that our root is equal to 0.74087 plus minus, so let's insert a symbol, plus minus 0.00005. Okay, we'll bold this, box everything, and we are all set. Okay, so this is our second lab, or second part of the lab. Okay, now before you submit, you want to make sure that your print setting is set. So let's make sure our print settings. So let's go to plotting. We are going to go to File, Print. And notice we don't have grid lines, we don't have our row column headings. So let's go to Page Setup. And let's not adjust as yet. No, let's not adjust anything. Let's keep it to 100% for the time being. So this is what you are going to see. So page setup, this is what you should see. When we go to sheet, we want grid lines, we want row column headings, and OK. So now notice everything fits nicely, but we are losing out some portion of the table at the bottom, right? So let's go ahead and shrink it a bit. So we'll say fit to 1 by 1. So I'll shrink it a little bit. Now everything fits on one page. Okay. Let's go check bisection method. File, print. Again, no row column headings. Let's go ahead, sheet, grid lines, row column headings. Okay. Everything fits within the page. Always notice the right border and the bottom. And since everything is okay, good. So file, save as. And remember, in my case, I'm going to save it as demo. In your case, you're going to save it as lab1. Okay, that is all there is to it. Check out your output format, grading rubric, which are next two slides. Okay, you can always magnify them in Adobe PDF to see the details if you want to. It is your grading rubric. Now in your grading rubric, you will see that I have itemized each item and given them a label A, B, C, D. So when your lab grader is grading it, if so let's suppose you have forgotten your name or date or something, and he takes off 1 point. So instead of writing all the detail, your TA is going to just write in the comment section items A, H, O, T, whatever it is, for which points have been taken off. All right. So always check grading rubric. That way you can make sure that you have all the elements in place. All right, folks.